Have you ever wondered where all the water on Earth actually came from? We take it for granted every day, but our oceans are vast. They cover more than 70% of our planet's surface and contain over 96% of all Earth's water. And while we know that all life on Earth needs water to survive, there's still a lot that scientists don't understand about its origins. Did it just always exist on Earth, or did it come from somewhere else? Well, a new study suggests that most of Earth's water may have been delivered by asteroids and comets from outer space. And if that's true, then these icy space rocks played a major role in kick-starting life on our planet. Let's take a closer look at this new research and everything you need to know about it. But a quick reminder before we start. Okay, so where does all the water on Earth actually come from? Scientists believe that most of it came from two places. One is the mantle, the layer of rock between Earth's core and crust, and the other is space. For a long time, the theory has been that the water we have now mostly came from the mantle. Basically, that Earth formed with a bunch of water already inside of it. However, that idea doesn't explain why some parts of the ocean have such high concentrations of hydrogen while others don't. It also doesn't explain why different ocean water samples have different stable isotope ratios. Isotope is just a form of an element with a different number of neutrons. So, for example, one type of hydrogen isotope is called deuterium, and it has an extra neutron compared to regular hydrogen. The thing is, when it comes to water, there's a difference between heavy water and regular water. Heavy water is simply water that has deuterium instead of hydrogen. And here's the key point. The ratio of deuterium to regular hydrogen in seawater is much lower than the ratio found in Earth's mantle. This suggests that some of the water we have now couldn't have come from the mantle because the ratios would be way off. Instead, scientists have concluded that the water must have arrived later on Earth's history. But where exactly did it come from? Now let's talk about comets. Comets are made up of ice and dust. That's why they're also known as dirty snowballs. When they get close to the sun, the heat melts some of their ice, which creates a cloud of gas and dust around the comet. These clouds can extend for miles and even shape the orbits of planets. Okay, great. So Earth could have just absorbed water from a nearby comet's coma. Except there's a problem. Scientists looked at a few comets and found that their water isn't suitable for life. The deuterium to hydrogen ratio is too high. Also, the amount of water comets deliver to Earth is pretty small compared to what we have now. This means that if comets did deliver Earth's water, it would have happened over and over again, like a long process of steady accretion. Except there's another problem with that idea. In order for Earth to absorb so much water from space without losing its atmosphere, it would have needed a really strong gravity. But early Earth didn't have a strong gravity. Plus, the atmosphere was mostly hydrogen and helium, not nitrogen and oxygen like today. So it wouldn't have held on to water very well. All of this suggests that comets weren't responsible for delivering Earth's water. This brings us back to asteroids. Asteroids are rocky bodies that orbit the sun, mostly found between Mars and Jupiter. There are millions of them, and most are made of rock and metal. Some are even humongous, measuring hundreds of kilometers across. But how could these rocky space rocks have brought water to Earth? Well, an international team of researchers decided to investigate a type of asteroid called carbonaceous chondrites. These are carbon-rich asteroids that contain organic matter. Most importantly, though, they bring lots of water to Earth, around 20% of their mass. A study published in Nature Astronomy shows that this water might have played a key role in the origin of life. Researchers studied 3 different carbonaceous chondrite meteorites and found that their water has a lower deuterium to hydrogen ratio compared to Earth's mantle. This means that the water from these asteroids could have mixed with the water from Earth's mantle without changing the overall ratio. Also, they discovered that this water has a unique isotopic signature. Each meteorite had a slightly different ratio, but all 3 were distinct from the water found on Earth today. This suggests that these asteroids didn't just bring water to Earth, they also played a crucial role in shaping our planet's water cycle. The researchers also estimate that these asteroids delivered around 20 times more water to Earth than comets did. But wait, there's more. Isotopic analysis revealed something truly amazing. The water in carbonaceous chondrites closely resembles the water found in deep sea sediments. Remember those sediments? They showed different isotopic signatures from the water in the mantle. Well, it turns out that the water in asteroids matches them perfectly. This strongly suggests that asteroids brought the missing piece to Earth's water puzzle. It's likely that they delivered it gradually over a span of about 10 million years. By shedding light on the origin of Earth's water, this discovery also helps us better understand the origin of life itself. You see, all life as we know it needs liquid water to survive. And the conditions on early Earth provided the perfect formula for this. Shocking fact plus space plus origins of life. Perfect formula. Now think about it. If Earth didn't have enough water, life couldn't have evolved. The water from asteroids seems to have kick-started it all. Now let's think about the bigger picture. This research contributes to our understanding of how water, a seemingly simple molecule, plays a crucial role in the formation of life. As scientists continue to explore other planets and moons in our solar system, they'll be on the lookout for signs of extraterrestrial water. Discovering water elsewhere could indicate the possibility of life beyond Earth, making the search for water a central focus in planetary exploration. But wait, there's more to the story. Not all carbonaceous chondrites have the same water composition. There are at least 6 different types of carbonaceous chondrites, and their water differs in oxygen isotopes. To solve this mystery, scientists will have to collect more carbonaceous chondrite meteorites and conduct further analyses. NASA's Psyche mission, for example, aims to explore an asteroid named Psyche that's located between Mars and Jupiter. Although it's not a carbonaceous chondrite, Psyche is a metal-rich asteroid that could provide valuable insights into the composition of Earth's core. By studying asteroids like Psyche, scientists hope to unravel the secrets of our planet's formation and evolution. And here's a fun fact for you. Asteroids aren't the only things delivering water to Earth. Even the moon plays a part in this cosmic delivery system. During the Apollo missions in the 1960s and 70s, astronauts brought back samples of moon rocks. And in 1973, scientists discovered something incredible. These rocks contain tiny glass beads called microtektites. These beads are formed when meteorites hit the moon's surface and vaporize some of the rock. And guess what? Some of these microtektites have a water content similar to Earth's water. This suggests that the moon is also a contributor to Earth's water supply, although it's hard to say exactly how much water it delivers. It's an ongoing investigation. So there you have it. Our planet's water may have originated from a variety of sources, including the moon and asteroids from outer space. The delivery of water by asteroids, particularly carbonaceous chondrites, played a significant role in shaping Earth's early environment and potentially setting the stage for life to emerge. As we continue to explore the cosmos, unraveling the mysteries of water's presence in our solar system remains a captivating quest. And who knows what other fascinating discoveries await us in the vast expanse of space. And with that, we've reached the end of this SCI Show space video. If you liked it, don't forget to hit that thumbs up button and subscribe for more updates on all things space. And if you want to keep learning about the universe, check out the additional resources. Thanks for watching and keep looking up.